So we're still working with congruent triangles. Every lesson I want to stress that congruent triangles are exactly the same size and shape. So all the sides of congruent triangles will be equal, and all their corresponding angles will also be equal. And so far we've done proving triangles are congruent by finding 3 sides are equal, or we did 2 angles on a side, and side included angle and side. In the last lesson, we proved 2 triangles are congruent using this reason over here. The right angles are equal, the hypotenuse equal, and one other side. So it says if the length of the hypotenuse, and just very quickly before we go on, hypotenuse is always the longest side in a right angle triangle, and it's opposite the right angle. So if the length of the hypotenuse, one side of a right angle triangle, are equal to the length of the hypotenuse, and a side of another right angle triangle, then triangles are congruent. The reason we use is right angle hypotenuse side. So it may seem a bit complicated, but let's see how that works. So in this example, we're going to prove 3 things, because I want to just touch on proving something from congruency. But the first thing we're asked to do is prove that triangle MNO is congruent to triangle MPO. Let's mark off our triangles. MNO, that triangle, is congruent to this triangle here. Okay, and we see that they're both right angle triangles. We know that because of this little sign over there that shows me it's a right angle triangle. So, in this right angle triangle, this side opposite the right angle is equal to that side that's also opposite the right angle. So, before I go any further, in triangle MNO and triangle MPO, I want 3 things. 1, 2, 3. And I've got that MN is equal to MP, and that's given. But that's very special, because this is the hypotenuse. So I've found already that the hypotenuse in the yellow triangle is equal to the hypotenuse in the red triangle. Great, I've got a hypotenuse. I've also got O1 is equal to O2. And that's given. Let's just write equals 90 degrees. And that's given. And that's special because that's a right angle. So I've proven the hypotenuse in each triangle is equal. I've got a right angle in each triangle that's equal. And so I'm looking for one more side, because I've got right angle, hypotenuse, one more side that's equal. And that's pretty straightforward. There's a side in both triangles. That's a common side. So MO is common, because it's in the yellow triangle and the red triangle, it's the same length. Therefore, triangle MNO is congruent to triangle MPO. And what did I prove? I proved the right angle, I proved the hypotenuse, and I proved another side. So right angle, hypotenuse, side. So if we've proven those triangles are congruent, what does it mean? Well, it means that MN will be equal to MP, because in my congruency statement here, MN is equal to MP, and I've also shown NO will be equal to PO, and lastly we showed that MO is equal to MO. Well, let's look at this. In this part here, we're asked to show that NO is equal to PO, and there we've got it. We've got it in our congruency statement. NO is equal to PO. So we can simply say for B, from congruency, it's just easier to shorthand that, NO is equal to PO, equal. And the question C says M1 is equal to M2. And how do I know M1 is equal to M2? I read off here. M comes first and M comes first. So in the yellow triangle, M is equal to red triangle M. That's right. So C, also from congruency, M1 be equal to M2. It's there. It's in my congruency statement. Right. So that's congruency done. I hope that helped. Now let's just work on some examples.